In this problem, we will check whether a given number is additive or not. And you will be given a number in the form of a string. So it will have digits from 0 to 9. And the definition of additive number is that the previous two numbers, it can be 1 digit, 2 digit or more digits. So you should group this given string into digits, contiguous digits. You cannot skip any digits, such that if these digits represent first number, these digits represent second number, then immediately following this we should have digits representing n1 plus n2, and this should hold till the end. That is, these two sum to this and these two sum to whatever follows, and so on till we reach the end. So let's see an example here. So you can see I have grouped them in different colors. So you can see that 1, first of all, its length should be at least 3 characters, otherwise you cannot find the sum of previous two and add a third one. So minimum character length is 3. So if number of characters is less than 3, then it's not an additive number straight away. So now you see that in this example, 1 is followed by 99, there is no gap here, and we get 100, which is what follows. Then we look at next value. So 99 plus 100 is 199, and you can see exactly these digits follow this, and there is no more digit. So we have reached till the end and we did not encounter any violation. So this was a valid additive number. And one more thing you have to do is that this preceding zeros are not allowed, so that you cannot group the digits such that here we have some number, here we have some number, and their sum is, let's say, 501. So it's 501, and we encounter a spare 0 here. So it's not that I will group this into this group and this 0501 would be same as 501. No, that is not allowed. So if you cannot group by this 0 should be included in the previous only, it cannot occur as preceding number. So we will return false. Just checking that if 0 occurs in the beginning, we would return false is not correct, since 0 can occur individually also. So if 0 is there as a preceding number, it's better be 10. So 0 can occur even after 1. So if it's 1 followed by a 0, then followed by 1. So this is also valid. Here 0 is occurring alone and not as a preceding 0. So we will add all these checks in our code. So let's see how we will approach this problem. So here we will try all the possibilities. So we will use backtracking approach. So first we will do, we don't know what are n1, n2, n3 and how large they are, how many digits they take. So we will fix n1 here as just 1 digit. Then we will fix n2 here. So we have fixed n1. So let's fix n1. So n1 is 1. We will change it when we encounter some violation and backtrack, change n2. None of the values of n2 work, then we will come back and change n1 to include first 2 digits. So for now we will try with first digit only as n1, and n2 also we don't know, so we will take this as n2. So we know that n1 is this, n2 is this, so n1 plus n2 is 10, and we see that 10 is of 2 digits. So if these two are n1 and n2, then next 2 digits should be, next 2 digits of the string should represent 10. But we see that it's 91, so this is not valid. So what we will do, we will backtrack. We know that for this value of n1, this n2 will not work. So what we will do, we will take n2 as 2 digits. 1 digit of n2 did not work. Now we will try with the next possibility. Then we will see n1 plus n2 is 100, 1 plus 99. And we know that this is 3 digits. So we will take a substring starting from here and we will take 3 digits. and we will see that if this matches with n1 plus n2 or not. Luckily for us, it matches. So we will see that till here it's valid, but we don't have to stop here. This validity should be till the end. So what we will do, we will continue this search. So now n1 comes here. We have to look for this sums to next. So till here it's valid. n2 is this one, and we see that now n1 plus n2 is 99 plus 100, that is 199. So again we check how many digits it takes. It takes 3 digits. So we will take a substring and pick 3 digits starting from here, and we will convert it to number and check if it matches 199 or not. So it matches. So it's fine. Here also it's valid. Now we will move n1 here, n2 here, but we see that here we don't have anything, so we have reached the end. If we had not reached end, let's say there was some digit remaining here, 55, then we would have taken this 100 plus 199, that is 299, again 3 digits. So we would see that 3 digits are there or not. So 3 digits are not there, so it would have violated. So either it should be empty string or it should be exactly this value. So in this case, we got this validity check done very easily with just first try of n1. Although for n2 we did backtrack one time. So what was the recursion tree that we draw? We fixed n1, then we took 9 as n2, and then we encountered a violation since the next 2 digits were not 10, not equal to 10. So we stopped here at this branch. Next, we took these 2 as n2, that is 99. So it should encounter 100, and we got 100 here. And then we took these 2 and we encounter 199, and then we reach the end of the string and we reach the validity check. But let's say there was some number where we need to backtrack for n1 also. Let's take one example. Let's say we have 2, 3. I am creating this number. Let's think that these are n1. Then we have 14. So these will add to 37. And these two will add to 51. Let's say this is the number. Although we know what is the value now. Let me write it uniformly. 2, 3, 1, 4, 3, 7, 5, 1. So this is the number given to us. We don't know the solution yet. So we fix n1 here. We fix n2 here. And we see that n1 plus n2 is 5, which is of 1 digit. So the next digit should be 5, but it's not. So we will backtrack. So this value of n2 did not work. So we will try 2 digits as n2. Now it's 31 plus 2, 33, which is of 2 digits. So pick the next 2 digits, see if it's 33 or not. No. So this value of n2 also did not work. Next, what we will do, so we are using backtracking, you can see. Next we will take 3 digits. This is 314. 314 plus 2 is 316. 3 digits. So pick the next 3 digits. Is it 316? No. So this value of n2 also did not work. So this time we are not so lucky. Next we will try 4 digits. This is n2. So this is 3145. This is 4 digits. So we will see next 4 digits are n2 or not. So we don't have 4 digits. So it's false. It did not work for any value of n2 for a given n1. So now we will backtrack all the way up to root, that is n1. So what we tried, n1 was 2. We tried 3. It did not work. We tried 31. It did not work. We tried 314 and so on for n2. So this is n1. This is n2. None of the values of n2 worked. So we backtracked all the way up here and try a different value of n1, that is 23. So for n1 equal to 2, it will never work. Next, we come back all the way up to n1 and take next n1, that is 2 digits. and then we take this as n2. Then their sum is 24, that is 2 digits. So check whether the next 2 digits is 24 or not. It's not, so we backtrack. We take different value of n2, this time 14. Their sum is 37, which is of 2 digits. So we will check whether the next 2 digits is 37 or not. And it's 37, so we are good to go. Till here it's valid. So next we will move everything. So this becomes n1, this is n2, and now n1 plus n2 is 51, which is 2 digits. So we take next 2 digits and check whether it is 51 or not. So it's 51, so it's valid till here. Next we will shift again n1. So we should do this check like Fibonacci number, like 1, 1, 2, 3, 5, 8, 13. So every previous 2 is sum of next is sum of previous 2. Similarly 2 plus 1 is 3, 3 plus 2 is 5, 3 plus 5 is 8, 8 plus 5 is 13, and so on. So now we shift n1 here, n2 here, but this is empty now. So we will return true. And there can be a base case, like let's say we have 2, 3, 1, 4. So here also it's n1, it's n2, and we get an empty string. But the difference is that here we did not even encounter a single match, since we did not get n2. But here we moved next when we found a match. So we set some boolean that we had found a match till here. Initially it will be set to false. So that way somewhere it will end the string. This is not infinite string, so we will encounter this situation somewhere for the last pair. So the difference between this and this case is that here we had found a match till this point, and then we ran out of string. Here we ran out of string right in the beginning, so we did not even find any n3. So here we will return false. Here we will return true, since this is inevitable. We will reach this situation sometime. So that is the idea. We will try different values of n1, n2 and find whether the next set of digits represent n3 or not. So let's write the code for this, and we will do it in C++ and Python. For those who are coding in Java, they can easily convert the C++ code to Java. There should not be any difference there. So this is the problem. You can go through a couple of examples. Both examples are for positive case. So we have to try different values of n1. So what we will do, I equal to 1. So these will denote the substring's length, you can say. And I should be less than. We cannot go till the end, since we have to consider for n2 and n3 also. So if n1 goes till the last digit, then there is no room left for n2 and n3. So I should be less than n minus 1, and n is num dot length, the size of this string, that is number of digits. So it will go till n minus 2, and plus plus I, and next we have to check for n2 also. And this n2 will start only after n1. So from I plus 1, and it can go till 1 more than this. That is, if this was less than n1 is 1, so this will be less than n, plus plus j. And now let's take the substring. So num dot substr 0. So n1 will, first we will try starting from, n1 will always be in the beginning, So we are trying different values of n1. Only after we find a match, we make n2 as n1 and n3 as n2 and pass this substring for the check. So in the main function, we will always start n1 from 0 till I. So this I is not included. This I denotes number of characters to take. So I is 1, that means pick one character. Then I will be 2, then pick 2 characters starting from 0. And this will be in n1. And this can be a long value as well. We will make it everything long. This can be a big number. So this is the n1. We will fix n1 and then try different values of n2. But if let's say we have a value like this is, instead of this number, this is a valid additive number, but let's say we have 0, 2, 3, 1, 4 and so on. And only valid case will be that this n1 is 0 alone. If we take this as n1, then this is invalid. Let's say it works for this. If we take these as n1, this as n2, then 37, 51, then only by grouping this with n1, it's valid. But we are not allowed to take this. If 0 occurs in the beginning, better it be 0 only, single 0, not even 2 zeros. So we need this check. So what we will do, whatever is the value of n1 in this string, we will convert it to number. So it will convert it to 23. Then we will check if this 23 is same as, we will convert it to a string and we will check if this matches with this or not. So it will not match, since this string has 3 characters, it has 2 characters. So we will return false there. We will not continue with n2 and n3 for that value of n1. Similarly, if some value occurs, like if this is 23014, then again if you group this together, it will be valid. But here n2 has a 0 in the beginning, where it's not 0. n2 is not overall 0. So again we will not check further for n3, but we will backtrack. And we will take next value of n1 and we will try 230. So these checks we will add here. So if to a string, so we converted this to long and we are again converting it back to string, is not equal to the original substring, that is this one. Then break, that is try the next value of I, or rather continue here. But in the case of I, this will be always from the beginning. So if 0 is in the beginning, it will be there for all the prefixes that we take. If 0 is in the beginning, then this case is valid. This number will return same as its string representation. But for all the subsequent digits, that is 2 digits of n1, it's 02 invalid, 023 invalid, 0231 invalid. So no need to even go further. Try next value of I. When you encounter this situation, you stop your check. It will always be false. So only it will run for the first iteration, and from the next value of n1, it will not work. So we don't need to check further. Instead of continue, we will break from here. Then again, similarly, we will have n2. Same way, exact same logic. Num dot substr, and it will start from I. since here I was not included. So here 1 digit means that it will take only 0th index. If it's 2, then it will take 0 and 1 index. So I will be 2, so here a starting index will be 2 and the length will be j minus I. And again the same logic. And we will define a recursive function that will do the backtracking part. Let's call it find or find rec for recursive. Then we will pass n1, n2 and the remaining substring. J onwards. If we don't pass the length, it will go till the end. And here we are adding a value for this case that we discussed, that if it's like this, then n1, n2 is there, but for n3 we are passing an empty string and we have not found a match yet, so we pass a value of false. In this case, where there are many numbers and everything is valid, ultimately we will reach the end and n1 will come here, n2 will come here, and again we will pass this remaining string which will be empty. But here we have found valid cases before this call. So here this is a valid case, this is invalid case. So in the beginning it will be false. Once we found a match, we set it to true. And let's define this function. And the first one is long, second is also long. So for the last call, length will be 0, this should be empty. If this is not empty, then we will proceed further, we will continue our check. But if it's empty, this is string, then we will check if it's coming from the base case or it's coming from this recursive call itself, where we will, if we find a match, we shift everything and again call this so that we reach the end. So if it's empty and it's found is true, then we return true. That is, it's valid till the end, we have reached the end. Otherwise, string n3 equal to so we add n1 and n2 and this is string n3. So whatever is the substring, it may be a big substring, it may be a small substring. Maybe that n1, n2 adds to 100, so it's 3 digits, but the past substring is only 2 digits. So we will take 2 digits and then compare, make the comparison. So min of s dot length and this n3 dot length. So we check that many digits in this past substring and we compare with n3. If it matches, then we need to proceed further. So n1 becomes n2, n2 becomes n1, n3 becomes n2, and the remaining string is again passed to this function. and here we will pass this true. So this is the only difference. So n3 is a string, but we need long, so we will convert it to long. So if we are getting match, if this does not match with n3, then it will come here return false. And we will come here and we will try next value of n2. If none of the value work here, then we will come here and try next value of n1. And if none of these work, we will return false. So we got a wrong answer. Let us check why this is so. So there is an error here. We were getting this false for this true because this call will return true if it reaches till the end and everything is valid. We are capturing it here, but we are not returning it here. So if found, then return true. So it will return from here all itself. But if it did not find, it return false, then we will not return from this main function. We will try for next value of n2 and then further next value of n1. But if it found a correct path till the end, which is valid additive number, then we return from here itself. So this was required. Now it's working. Let's submit. So it's on the lower side only, 4 milliseconds, so we can expect some fluctuation here. Now it's 8 milliseconds. So you can try a few times. I am pretty sure it can reduce further. So now let's try it in Python. Or we can check for empty string also. Yes. Uh, so in C++, the second parameter is in the substr is the length of substring starting from this index. But here in the splice, it's from index I to the given index before that. So this index is not included. So starting from I of length j minus I, that is here it should be j minus I plus I, that is j. So this is the syntactical difference. And this is accepted in Python as well. So hope you understood this problem well. It's an important problem, and if you are able to solve this, then you will get a good practice in backtracking. And here you can see that the submission acceptance rate for this question is very low. That is, out of 173,000 or roughly 174,000 submissions, only 50,000 are accepted, which is less than 30%.